Acha, when we used to talk about differential calculus, right? What we used to do, we used to find the slope of a particular curve, right? If you remember. Now then it will become interesting. See, y equal to fx is a function, right? And differential calculus for us is over now. But still, let us have a quick look at what did we do here. Differential calculus. So y equal to f of x was a function that was given to us. And you tried to find out what? You tried to find out dy by dx, which you wrote as f dash x. Now what is f dash x? F dash x is the slope function of this particular main function, the parent function. So if this was like quadratic, then a quadratic function will be like a parabola, and the different derivative function would be a linear function, which will be a straight line. I hope you understand that now. Parabola's slope will always be a straight line. Similarly, if this was cubic, then this will become quadratic, right? So differential calculus is all about finding slope, right, at a particular point. We now shift our thought and we get into something called integral calculus. And we will see what all we will study in integral calculus. Let us first try to have just a brief idea. I mean, that, what do you call, the finesse will develop as you slowly do more and more calculus. You'll understand what exactly I'm trying to say out here. Okay. While differential calculus was dealing with what is known as the slope, in integral calculus, let us say this is a function. Okay, this is a function plot, and I say this function is y is equal to, say, f of x, right? This is a function. What happens when you integrate this function? Okay, integration tells us the area under a curve. Go back to your physics. You used to do two things: slope and area under the curve. Okay, so let's say, I'm just trying to give you a brief idea. Let's say I want to find out what is the area. I want to find out what is the area under the curve from, say, these 2 points, right? Let's say this is x equal to a, this is x equal to b. I wanted to find out what is the area under the curve, which is y equal to fx for the values from a and b. Understood? In this interval a and b, or I'll say close interval a b. Now think, if this line, if this curve was a straight line parallel to the x-axis, your job was very easy. You would have just found out the area of the rectangle, right? So now what we do the same thing, but here what we will do, we will make many infinitesimally small, what do you call, I'm very sorry, okay, infinitesimally small partitions we will make out here. It's very small partitions. Let's say this is one partition, fine. Then this is one more partition, all right. Then this is one more partition. Are you understanding? Each partition has a width which is equal to, say, dx. Dx is the width of each partition. Dx is the width, right? And what you do for the time being, say you are concentrating only on the first one, okay, the first rectangle. Just take the first, and these are very, very small partitions. So if I tell you what is the width, of this small rectangle, is this dx, and say what is the length or the height, okay, what is the length or the height, is it not fx? This is fx, right? If I plot the function out here, then is it not fx? This height is fx. So what is the area of this particular rectangle? The area of this particular rectangle would be f of x into dx. Do you agree? Now if you look at the next one, there is a f of x, but a slight more increment. But if you make that it very, very small, so it is all f of x plus small h, f of x plus small h into dx. And we can't add the areas of all the rectangles, because if you add the areas of the rectangle, you would be getting some area of a rectangle only this much, see, only this much. But what about these portions? Also, there will be a loss of area in these portions also. Like, see, this is small, so there will be a loss on the top part also. There has to be a loss. So here, summation s, the summation s transforms into integral, and the integral is written like this. And we integrate many of this f of x dx, and you integrate it from a to b, from a to b, from a to b, and this gives you what is known as area under fx within the interval ab. This is a broad idea of integral calculus. In integral calculus, all we are trying to find out is area under a curve. In differential calculus, all we are trying to find out is, we are trying to find out slope of a curve. Okay, na? Yeah. But in none of your problems, you will be doing like this until and unless you come to definite integrals. Now let's take another perspective of it. What are we going to study in integral calculus? Our first study would be indefinite integrals. Indefinite integrals. If you know this, indefinite integrals means you will have an integral, you will have a function and a dx. You have to solve this. There will be no limits assigned. This is called indefinite integral. Then we will get into a chapter which is known as definite integral. Definite integral. Here we will be integrating a function fx dx and from a to b. Okay. After this, we'll get into a chapter called application of integrals. Integrals, AOI. As you had application of derivatives, and then we will have differential equations to sum up. And this will take us at least 3 to 4 months now from here. July, August, September, October, November, maybe at least, not less than that. Okay. So we start with indefinite integrals and let us see what we are doing. Given a function f of x, given a function fx, if you differentiate, then what you get is f dash x, which is known as the derivative. Which is known as the derivative of fx. Right. Now, if you take f dash x, which is the derivative, and you try to process what is known as the antiderivative, this is how foreign universities will teach you. Antiderivative, what we call as integration, is basically antiderivatives. You come back to the parent function fx. Simple story. Differentiation, grandfather gave me grandson. Integration, grandson will be integrated and we will get the grandfather back. Is this clear? You cannot do integration if you don't know differentiation. So all differential formulas will be required because you will be processing them in the ulta way. Maida gives rise to bhatura. Bhatura should give back maida in that manner. Right? And you have to remember what gives what. Milk gave cottage cheese gives me back milk. So far you understood only milk to cottage cheese. So now you won't see milk. You'll see cottage cheese. That time don't say maida. Cottage cheese comes from milk. That you have to remember. ठीक है? कोशिश करें. आइए धीरे-धीरे कोशिश करते हैं. Let's say let's do it with the trigonometric function. Okay, very formula intrinsic initially, but I know if I'm teaching it this way, this is like a formula root sort of a progress. But this is how you will learn. Initially, let us learn how to solve problems. Then we'll get to know the better of it when we do application of integrals, definite integrals. Okay, let's take some trigonometric functions. Okay, some trigonometric functions. Let's take trigonometric function and let's start. Number one, ddx of sine x. Tell me better, what is it? Cos x. Understood? So we see the integration part. Cos x multiplied by dx. So integral of cos x dx will give me sin x. Now, since you are doing indefinite integral, it will always have some constant of integration. Don't break your head too much now. I will show you what this is. This is called a constant of integration. You can write C, right? But that C should be written. And sometimes you'll get, you are integrating, say suppose you are integrating two functions. You get a C for one. For the other one, what do I write, sir? I write a C1. Sir, can I club those two and write something called K? Yes, you can write K. These are constants. Just write K is equal to C plus C dash, whatever it is. This is the first one, right? Let's see the second one. The second one is d dx of cos x is equal to negative sin x. Agreed? All right. So let's see what is this integral part. Integral, see, sin x into dx. Now I'm not taking the negative. So the function will come up as negative cos x plus c. Did you understand? The same thing. समझ में आ रहा है थोड़ा थोड़ा? Not that tough, huh? चलो, number 3. d dx of tan x is sec square x. That means integral that means I'll write integral sec square x dx is equal to tan of x plus c. Okay? 4. d dx of sec x. What is it? d dx of sec x? Sec x tan x. Okay. Sec x tan x. This will be integral sec x tan x dx is equal to sec x plus c. Which one? No. Root and all doesn't work. Differentiation in it. Integral sec x will be log sec x tan x. That will come later. Okay. 5. d dx of cosec x minus cosec x cot x. Therefore, integral cosec x cot x is minus cosec x plus c. Fine. 6. d dx of cot x minus cosec square x. Therefore, integral of cosec square x dx is equal to minus cot x plus c. We're done with the basic trigonometric ones, okay? Fine. Let's take some other ones. Exponential. d dx of e to the power x is e to the power x. All right. So we can write integral e to the power x dx is equal to e to the power x plus c. ठीक है? d dx of log x means ln x is 1 by x. Integral dx by x or 1 by x dx is the same thing. See, 1 by x dx or dx by x is log x plus c. Okay. Now some interesting ones. This one you need to take some time to understand how we write it. See, d dx, look here, d dx of x to the power n is nx n minus 1. Nx n minus 1. Understood? Now the problem that happens is this is n minus 1. N minus 1. I can write a formula with n minus 1. I would like to write a formula with integral x to the power n. Are you getting it? Integral x to the power n. So I change this, means I change this as ddx of x to the power n plus 1. Tell me children, what will the value? N plus 1 x n plus 1 minus 1 is n. Have we understood this? ddx of x to the power n plus 1. N plus 1. No, just now you forget this. You forget this. 1 minute. I am asking you what is ddx of x to the power n plus 1. चलो ऐसे देखते हैं. nx n minus 1. So this is n plus 1 x n plus 1 minus 1, which is n. ठीक है ना बेटा? समझ में आया? Now I am doing it like this. I want to find out integral of x to the power n, integral of x to the power n into dx. But you will say, sir, what did you do with this n plus 1? Your point is correct. So let's take that n plus 1 also. So let's write, I'm just trying to formulate the formula. N plus 1 x to the power n dx. Now does it look good, like the way you've been solving for all? Right? What would you write this as? X to the power n plus 1, right? Plus say some constant c dash. Sir, why did you put c dash? देखो, पहले देखो. Why did you put c dash? You'll ask. There should be some constant. Now this is a constant. Can the constant come outside the integral? Very much. I can write this as n plus 1 integral x to the power n dx is equal to x to the power n plus 1 plus my c dash, whatever it was, right? Now I formulate my formula. What is x to the power n dx? See, in differentiation also, your standard formula is ddx of x to the power n, not some n plus 1 or n minus 1. So in integration also, it should be some n. You don't write it as n plus 1 and all. So what will this be? X to the power n plus 1 divided by n plus 1 plus c dash divided by n plus 1. Do you agree or not? So finally I can write integral x to the power n dx is x to the power n plus 1 divided by n plus 1 plus 1b, are same constant c, where c is c dash n plus 1. This is the only thing you should remember. How this formula comes. People remember it. I just showed you how the formula comes, and with this you should be good to go to solve problems. So let's take the 9, and if more question comes, we'll take it up. X to the power, sorry. So here I am writing ddx of x to the power n plus 1 is equal to n plus 1 xn. So integral x to the power n dx is equal to x to the power n plus 1 by n plus 1 plus. Achha. Now you may ask a question. You may ask a question here. I'm keeping this, Ash. You may ask a question to me. But sir, if that be the case, why did you not solve this as per formula? You could have written it as x to the power minus 1 dx. You could have written this as x to the power minus 1 dx. If I write it as x to the power minus 1 dx, by my formula, what it should be? X to the power minus 1 plus 1 divided by minus 1 plus 1. So ये undefined हो जाएगा ना बेटो? Did you get the beauty? I can't do it as, I can process this like this. If you process this, then it will become x to the power minus 1 plus 1, which is x to the power 0, which is 1. But the denominator will become a 0, which is undefined. That's why we don't process. Okay. Now I'm rubbing this much motion. I hope you have understood this much of formulas. Initially, they are sufficient for you. And these are the fundamental formulas with which your vehicle will be moving initially. Okay. Have we understood? These are our basic fundamental formulas with which our Gadi will be moving. So shall we start our exercises? They're very easy. So They've given you a lot of formulas, but we will see one by one, slowly and softly. Okay. They're saying method of inspection. Forget all those method of inspection. Let us try to do. Let's take a question. Let's take a question. Integrate 3x squared plus 4x cubed. Now, children, the right way is to actually put a bracket and write dx out here. Integration is always done for fragments. Dx. First, you don't need the book. First, we'll do from here, then we'll take the book. Don't worry. We'll do it. Okay? Acha. Whenever you have integration of two functions, fx plus gx, you can integrate each separately. So I can write this as what, beta? I can write this as integral 3x squared dx plus integral 4x cubed dx. Step by step, slowly we will go and we will be able to do. Right? Can I write this? Next, see, constants can always come outside. Fine. Now see, every time don't need to keep the formula in your mind. When you used to differentiate, did you at last keep any formulas in mind? You used to do, suppose 6x squared, you should straight away do 12x. X square, there it is to reduce, here it will increase. It will become x cubed by 3, x cubed by 3. 1 minute. When you saw x cube and you wanted to differentiate it, what did you write? You brought the 3 as a multiple, x square karte the aap. Okay? Integration is everything ulta. Integration is everything ulta. You brought a multiple, now it will become a factor. And this will go up. You used to reduce, this will go up. And did you not do your formula? N plus 1 divided by n plus 1, 3 plus 1 divided by 3 plus 1. So we can do it in that manner also. Okay. धीरे धीरे करेंगे, फास्ट होता जाएगा, कोई बात नहीं. आइए. So 3x cubed by 3. Now I should get a constant, say, now there are two expressions. So let me put a constant C1 for this. Right? And 4x4 by 4 plus C2. पक्का बच्चा? 3 and 3 cancel each other, 4 and 4 cancel each other. I get x cube plus x4 plus c1 plus c2, which I am writing as x cube plus x4 plus c. Plus c. Grandchild gave me grandfather. Let us differentiate this. इसको differentiate करो. 3x square plus 4x cube. C is a constant whose differentiation is 0. Did you understand? थोड़ा सा. Maybe 0.001. Did you understand? Very good. Okay. Our problems actually start now. Let's do one more. आराम से करेंगे. X cube minus 1 divided by x square. How do I integrate this? Achha, what formula do I know? I know with these type of, I know two formulas. Dx by x integral I know. See, this is me. I know only two formulas. Integral dx by x, which is equal to log x plus c. You should see 1 by x is log x. I know another formula. Integral x dx is equal to xn, n plus 1 divided by n plus 1 plus c. I don't know anything other than that. You buy, beg, borrow, steal, you have to bring it back to this form. You have to, इसी screwdriver से खुलेगा. That you know, whatever. So let's see what we can do here. Can I write this as x cubed by x squared minus 1 by x squared And can I put this as a dx out here? Right? Two different functions. So this becomes how much? X minus 1 by x square, and this is a dx. Do you agree? Right? Can I write this as integral x dx minus integral dx by x square? I can write this. Acha. Can I write this as x to the power 1 plus 1, that is 2, divided by 2 plus a constant of integration c1? Right? And this one, can I write this as x to the power minus 2 dx? Formula लगा देते हैं. This formula does not work only if minus 1 is the power, because if minus 1 is the power, you have to use log x वाला formula. See. If minus 1 ये यूज करोगे, minus 1 जोड़ के कुछ भी है ये यूज करेंगे. ठीक है? तो I can write this as x square by 2 plus c1 minus x to the power minus 2 plus 1. बेटा क्या होता है? Minus 1 divided by minus 1 plus say a c2. And you can actually put the bracket here, because you will say, sir, the c2 should be that. C2 and c1 is nothing of your headache. So your final answer would be what? X square by 2, right? And this is a minus 1. Minus minus becomes plus. So this will become a plus 1 by x, basically. And a c1, c2, you can all do whatever you want. And you can write this as a capital C. And you can write capital C is equal to c1 minus c2. That's it. Did you understand the answer? Look here. Minus 1 and minus becomes plus. And x to the power minus 1 is 1 by x. So, one more interesting thing. Just look here. If you get something like dx by x square as integral, what is it resulting in? Your power will always get reduced and a minus 1 will come outside. Did you understand this? Look at from this step. If you get an integral of this, finally it becomes this, and the minus always comes out. The minus 1 always comes out. So in later stages, you need not break up so much. From here, you can straight away write this. Did it get clear or not? See, here we had a minus, so the final sign changed to plus. But otherwise, the dx by x square is always equal to a minus 1 of integral. Sorry, not integral. This integral sign won't be there. Sorry. The integral sign won't be there. It will be minus 1 by x. Okay? Clear? 5-6 problems we'll do. We'll get an idea of how to do problems. Chaliye. Can you try this problem on your own? Don't look at the book, okay? Can you try this formula on your own? Simple formula. Split it into two functions. Use the formula of x to the power n dx. Acha. Look, we can separate it like this. Dx is what, beta? Very small. And you are integrating a lot of small dx. What will you end up with? Dx is very small. The edges of cakes, if you add up the edges of all cakes, what will you get? Cake. X. So this will become x to the power 2 by 3 plus 1 divided by 2 by 3 plus 1. And now I won't do any C1, C2 anymore. I'll straight away write C. Now let's do this. 3 plus 1 is how much, beta? X to the power 5 by 3 divided by 5 by 3 plus x plus c. So it becomes x to the power 5 by 3. So this becomes 3 by 5. है ना? Plus x plus c. Getting little bit hang of the thing? Thora thora. Thora thora. Next one. X to the power 3 by 2 plus 2e to the power x minus 1 by x dx, and we are integrating it. ठीक है, चले, let's do. So this can be written as integral x to the power 3 by 2 dx plus integral 2e to the power x dx minus integral dx by x. ठीक है? First one will become what? X to the power 3 by 2 plus 1 divided by 3 by 2 plus 1 plus 2 integral e to the power x dx minus, this is what? Log of x. And log x, when we write, always put the x in modulus, because log can never be done of negative numbers. In fact, I should have also changed my first, where it's gone. Yeah, yeah, it's log x, log modulus x, okay? Log of mod x. चले, इसको और आगे करते हैं. So 3 plus 2 will become 5, x to the power 5 by 2. So this will become 2 by 5 plus 2 e to the power x minus log mod x, and a c is the constant of integration. Job is done. ठीक है बच्चा? So lot algebraic we did. Time for us to dive a little bit into trigonometric ones. Shall we? आ जाओ. One more example. Sin x plus cos x dx. Question. Sin x plus cos x dx. How do I write it? I split it into two functions. Sin x dx plus integral cos x dx. Sin x dx is negative cos x and cos x is sin x plus c. If you want to better it, you can write sin x minus cos x plus c. Now children, differentiate this. What is ddx of sin x? Cos x. And ddx of cos x is minus sin x. So this is minus plus sin x. Next problem. Integral cosec x plus cot x dx. These are all formula based. ये easy है एक सब. अभी you have actually, these are the daytime shoots of a horror movie. So nothing has actually come out. Once the sun sets in, and then only you will see what is the impact. Acha, cosec, cot, cos, these are all shaitan. They're always negative. They'll always be negative. So ddx of tan x is sec square x. ddx of cot x is minus cosec square x. So this will be minus cot x. And ddx of sec x is sec x tan x. ddx of cosec x is minus cosec x cot x. So this will be minus cosec x and a plus c. Job done. ये जो आप सोच रहे हो ना, how he is very quickly swapping those derivatives and anti-derivatives, this will become clear to you also. You just have to learn how to do the ulta job. It's like cycling. pedal this way, and initially when you pedal the opposite way in a gym or something, you feel if something is going very wrong, but after some time you'll get that synchronization will match. Chale? Now let's do one more. 1 minus sin x by cos square x dx. Question. 1 minus sin x by cos square x dx. Okay. So let's see. This can be written as 1 by cos square x dx minus sin x by cos square x integral dx. So it's standard formula में आ गया. This is integral sec square x dx minus integral sec x tan x dx. Sec square x means tan x minus sec x plus. Sin x by cos x is tan x and 1 cos square is. That's why they gave you like that. It will be sec x. समझ में आएंगे? Okay, let's see one more problem where your constant will become clear. So they're asking us, find the antiderivative f of f defined by f of x is equal to. So basically, they're asking you find antiderivative of 4x cube, okay, minus 6x. They're asking you to solve this problem. For us, it is very easy. Okay, so we will write it as 4x cube dx minus 6x dx. So what is the value? 4 x4 by 4 minus 6x square by 2 plus c. Right? Finally, we can write it as x4 minus 3x square plus c. Now just pay attention what this was very easy because you are habituated to do the problem like this. The question they said was a little bit in a turn language, okay? So let's see what was the twist. Find the antiderivative f. Antiderivative is also a function. Find the antiderivative f of function f where f of x is equal to 4x cube minus 6x. So you are trying to find the antiderivative. Wait. Antiderivative of this function. Understood? So what is this f? The antiderivative is integration of f of x dx. That's exactly what you did. Got it? And therefore, find the value of f0. Find the value of where f0 is equal to 3. They have said that the value of f0 is 3 given f0 is equal to 3. Then they are asking you, this is given, you find the value of this. Have you understood? This is given to you, you find the value of this. The antiderivative is beta also a function of x. And while solving this antiderivative, what did you get? You got x4 minus 3x square plus c. Now this c, अब ये c के बारे में समझ में आया. This is constant of integration. So they have told you f of 0 is equal to 3. Now you put f0. f0 is 0 to the power 4 minus 3 0 square plus c. कितना आ रहा है बेटा? It is 0 minus 0 is 0. So f0 is coming as c. And given f0's value is given as how much? 3. Therefore, c is equal to 3. Under this particular condition, look, under this particular condition, this thing's answer will be x4 minus 3x square plus 3. This is a specific value when f of 0 is equal to 3. Then the constant can be abolished. Did you understand? Where constants come? This we will see more in definite integral. So this brings us to our cute little exercise of 7.1. Will you give a try? And I sit for some time, give a try,